yesterday after this class, I had a meeting at Presbyterian St. Luke's Hospital, which is just off Colfax, kind of by East High School. And it was a great meeting. We're looking at doing some medical internships there for kids, which I think is a neat opportunity for kids. And then I had a meeting that was over by Invesco Field, or whatever they're going to name the field, but where the Broncos play, with another doctor's office, which there's more internships there, which that was also a fantastic meeting. So as we pull out of Presbyterian St. Luke's, pull on to Colfax, and right in front of us is Voodoo Donuts, and there's not a line. Yeah. So we went and got a dozen donuts. Yeah, that was good. I ate way too many donuts yesterday, and they were way too good. And I kind of felt bad about it for a few minutes, but I really don't. Huh? It was. Hey, sunshine! Thank you for oh, got all kinds of mail. All right. Oh, it's all for Angelo. Oh, gotcha. You got mail. Your brother has mail. So after, yes, sir. What's that? There's a lot of things. One of them arming the security guards with AR-15s. Yeah. I'm not quite sure.
When did that happen?
It currently like taking place now.
Oh, they're trying to
Yeah, the district already bought 10 or 12 AR-15 semi-automatic rifles that the security guards will carry. District-wide. That's probably the high school. What's that? Well, I will tell you this. There was a few teachers I used to teach with down there that I never asked, but just because of how they spoke, I was pretty sure that they had something either in their bag or on their ankles. Pretty sure. That's
wait, which district did they
Southern.
DC.
Oh, they were like, you know, you can't, the Constitution gives us freedom to carry anywhere we want. The state shouldn't have the right to tell us we can't carry at schools and libraries and banks. Yeah, it was different. I'll just say that. Yeah, you know, pretty dangerous spot there. Yeah, so there's other things going on. I saw that down in Douglas County, there was a protest at Ponderosa High School a few weeks back, and the girl who set up the whole rally was pulled out of class the other day by 2 school board members, and she was smart enough to turn her recording device on with her phone and recorded the entire conversation. And it's pretty good. I'm good for her for doing that because, you know, I think those school board members are going to be pretty much saying, you need to resign. And one of them happens to be the school board president. Yeah.
What are you talking about?
Because she organized a protest based on we were losing too many teachers, which they're right. 70% of the teachers have left that district in the past 5 years, and it still continues to.
What was the protest about?
They want the evaluation system and the fairness. So what it comes down to is, when I was down there, I got up to making about X dollars for my salary. I was outside of the salary band because I didn't taught long enough. So the salary band says, well, you're allowed to make in this range. I was outside of it. So they said, well, we'll slowly roll you back into the salary band. I said, well, that's a pay cut. I'm like, no, don't think of that way. It was like $15,000, $16,000 less. I'm like, this is a pay cut. And then not only that, but in order for the district to save money, they told all high school teachers, you will teach 6 classes with 40 kids in each class. So when I first started in Douglas County, I taught 5 classes, and I could have a maximum of 130 students. Not bad. And then they changed it to 150 students, so the class loads increased. And then they said up to 240 students, 6 classes. At no extra pay.
Saving money.
Yeah.
How, if they bought like 15 AR-15s, those things are
So
$600 a
So I don't know if you all know this, but Douglas County, as a county, is the 6th richest county in America. It is the richest county this side of the Mississippi River. And now I understand if people say, "Oh, what about these houses up here?" I understand. This is Arapahoe County. There's a lot. This county's huge, and there's a lot of diversity throughout the county. But that is the richest counties per capita. This side of the Mississippi, 6th richest in the United States. They don't want to pay their teachers. Teachers do bad. When I was down there, I was told with our math department by a school board member that there's about 1,000 engineers willing to take our jobs and make less. It's like, really? Someone making $150,000 is willing to make like $40,000? You sure? It was so needless to say, you guys are in a really good spot. But I tell you, there's just goofy stuff going on, and I tell you, I'm sad about that. You count money back there?
Yeah. How much you got?
Almost got a buck. Almost got the Jimmy John.
Yeah.
All right. So, have you found any questions on the sheets that you'd like me to run through? Number 6. Okay, let me take a look at that. Number 6. Is this the one you're referring to?
I don't know where the number 6 came from.
All right. A value is 11, B value is 7, C value is 6. And then we know that x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So all those blanks are where we'll plug our numbers in. Agree? So x is equal to negative b. Well, here's my b. Plus or minus square root b squared minus 4ac all over 2a. Does that seem okay? All right, so let's drop parentheses and start working through it. So I get negative 7 plus or minus. How many answers does this mean now? 2. Okay. And then I get 7 squared, which is 49, minus, so 4 times 11 times 6, so it's going to be a negative answer. So 44, and 44 times 6, help me out, I don't have a calculator with me. Or 66 times 4, or 24 times 11. 264? Was it 264?
Yeah.
Is that right? Over 22? And then what is 49 subtracting 264, please? What is 49 minus 264, please? How much? I know it's negative.
Negative 15.
Yeah, okay. Over 22. Now, if you get to that point, awesome, okay? And I'll tell you, if you get to this point for your answer, I think you're totally appropriate to leave it. The extended version of this is for you to understand, and I'll give you extra credit. I'll give you a point extra credit if you realize that this means the same thing. What this does is this takes out of account that we have, this means it's a part of the complex number system, which means it will not cross the x-axis. Just for laughs and giggles, let's try and break 215 down into some perfect squares, okay? So we talked about it a little bit yesterday. You can go through your things. I think the best way maybe to think about this, though, that makes sense for people, is let's realize that, 3 doesn't work, 5 works. If you have your calculator, 5 goes into 215 how many times? 43. And then I know 5 and 43 won't break down. So this will not break down any further. So that looks like a good answer. So if you get to this answer, you're getting full credit for the problem. If you get to this answer, I'll give you extra credit. Okay? So realize if you have a negative under the square root, make the I come out front. You no longer will have the negative under the square root because the I is taking place of that. The I, notice, is outside of the square root, right in front of it. Okay? Other questions you might have come across on this? Four? Okay. Number 4, we have 8x squared minus 14 is equal to 0. My a value is 8. My b value is, like really? Okay. What's my b value up there? I will tell you my c value is negative 14. What's my b value? 0. It's not there, so it's got to be 0. Okay? All right. If I have a value that's 0, does my quadratic formula still work? Yeah. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Plug in our values. X is equal to negative b, 0. 0 squared minus 4ac all over 2a. Cool. So negative 0, 0, plus or minus. Looks like we're going to have two answers. 0 squared minus, minus times, that's going to be positive, right? So I have negative times positive times negative. And 4 times 8 is 32. What's 32 times 14, please? How much? 448? 448? All over 16. 0 added to that. Okay, so I want to break 0 plus 448, so I'm going to have a positive and negative answer. I want to break 448 down. Okay? 28 and 16? Really? 28 and 16. So 448 breaks down to 28 and 16. I like that. So the square root of 16 is 4, so I get 4 root 28. Will it break down any further? What does 28 break down to?
You can do 32 and 14 also.
32 and what? 14. That wouldn't help me as much because you were great with the biggest perfect square with 16, but there's still a little bit more. Thanks.
Yeah, how many times?
Can I break 28 down to another perfect square? 4 and 7. Shh. What's the square root of 4? 2. What does that 2 do with this 4? No. Multiply. So I get 8 root 7. How's that 8 root 7 now? Square root of 4 is 2. 2 times 4 is 8. And too much talking. Okay, so our answer to this problem, so if you get to this point, you're missing 1 point because you didn't get all the way down. So this is going to be 0 plus or minus 8 root 7 over 16. This is almost done. What still can take place? Yeah. I can reduce the 8 and 16, and some people might say, well, what about the 0? Well, 0 over 16 is 0. Okay, so this goes here, that becomes that. So I get 0 plus or minus 1 root 7, or what's root 7, all over 2. So here's my answer. Huh. 45 degrees? Sweet. Any others we want to take a look at? Yo. 8. Did I just do 8? Oh, I thought I did. 6, 4, 8. And this will be the last one. Should be good for us. 4n squared plus 11n plus 7 equals 0. Shh. A equals 4, B equals 11, C equals 7, X equals negative B plus or minus square root B squared minus 4AC all over 2A. All right, negative 11 plus or minus 121 minus, what's 16 times 7, please? 16 times 7? 112. 121 minus 112 is? 9. Square root of 9 is? 3. Okay, so I got negative 11 plus or minus 3 over 8. So negative 11 plus 3 is negative 8. So I get negative 8 over 8, which is negative 1. And then I get negative 8 minus 3, which is negative 14 over 8. What does that reduce to? Negative 7/4. So guys and girls, this problem originally, it actually would have factored out. Why do I know it factored out? Because we actually came down to two numeric values that did not have a radical involved, because we had a perfect square underneath the radical sign, which is called the discriminant, which that's where it is. All right? Okay. So, few things on the agenda. We will have a quiz tomorrow. I think we'll do fine on it. Okay. Part of the quiz deals with breaking down radicals. So, we'll break down a few radicals. So a few things. A lot of you are getting those school-ishy things done. Some of you still aren't. Okay, so let's get in there. All right, let's take a look at this worksheet. Turn to the side that has linear. That's the first thing. So things that you need to know about linear equation. You just have an x, or you have a 3x, or you have a 5x, or you have a negative 2x, or a negative 7x. Your x value is only raised to the first power. You can also have things that are added or subtracted to these things that are constants. Things like that. This creates a linear scenario. Linear, you want to get x alone. Linear has one solution. Linear is in the first dimension. It's just length. Okay, you've dealt with straight lines for a long time. Okay? Quadratic. So quadratic, I'll start talking while you guys are writing. Quadratic is made up of two linear equations that have been multiplied together. Okay? Meaning you FOILed. Quadratic, you have x squared. You have x squared as it is. You can have a constant in front of the x squared. So you could have 7x squared. You could have 12x squared. Okay? You can have a whole thing. You can have an x squared with an x term with a constant, which is a number. So you can have 5x squared plus 2x minus 7. You can try factoring them. You can try getting a greatest common factor out. You can try using the quadratic formula. They have two solutions. And it's up to two solutions because sometimes you only have one solution. And sometimes of the solutions you can have something called a complex solution, which means it won't cross the x-axis because it's an imaginary number. Okay, it'd be the square root of something negative. Okay, so that's quadratic. Quadratic, you're trying to get x alone. Okay, so when you use this, what is alone right here? X. Okay, when you use the quadratic formula, you dealt with something that was x squared. You had an a, b, and c value. The a value is attached to the x squared. The b value is attached to the x. The c value does not have an x attached to it by multiplication. Okay? Quadratic formula works well. You're trying to get x alone. Quadratic formula has x alone. Okay? Quadratic can have different looks to it. Okay? So quadratic, you could have something like this. You want to get x alone. So you could try solving for x. How I would approach this problem is I would realize this. I can do this. What did I just do? I moved the 6 over. I subtracted it. What's my a value? My a value is 2. What's my b value? 0. And my c value is negative 24. Can the quadratic formula work having a b value being 0? And it'll work nicely. Okay, but you need it to be equal to 0 for it to work. Okay, other times you could look at this problem and say, well, I could do this. I could factor out a 2. And I could see if I could solve it this way, because sometimes this might come out to something that's factorable. At this point, it's not really factorable. Okay? So I'd say the quadratic would work nicely on this. Okay? But there's other times on a quadratic. There's special case scenarios that come up. You have sometimes it's a difference of 2 squares, which factors down quickly and easily. Not tripping. I was tripping on the bucket. Trash can. So there's times your quadratic could look something like this. So sometimes you might be able to identify this as the difference of 2 squares. If you can't identify it as the difference of 2 squares, do you think you can use the quadratic formula on it? Really? My A value is 1. My B value is 0. My C value is negative 36. Can I use the quadratic formula?
Yes.
Heck yeah. But sometimes you might see this going, oh, this is x plus 6, x minus 6. That's what it factors to. That's the special thing with difference of 2 squares. That means I take x plus 6 and say it's equal to 0, and I take x minus 6 and set it equal to 0. So I get x is equal to negative 6, and I get x is equal to positive 6 for my solutions. Okay, there's way too much talking coming from the back part. I know you're excited because you got coinage. Let me ask you all this. If I had used the quadratic formula on this, what would my answers have been? Would they have been the same answer?
Yeah.
Yeah. So if you're like, okay, my go-to should be the quadratic formula because I don't always see special case scenarios. I don't always see the factoring. Is that okay? It works. Quadratic works on all of them, but then there were some special case scenarios that there weren't. Can I move on? So we have this problem. Guess what? It's a quadratic. How do I know? It's raised to the second power. A is equal to 2. B is equal to negative 8. C is equal to 0. Okay? Does the quadratic formula work when the C value is 0?
Yes.
Does the quadratic formula work on all quadratic formulas? Yes. That's why it's called the quadratic formula. It's not called the quadratic formula except in this case. It's called the quadratic formula. It works every time. X equals negative b plus or minus square root. B squared minus 4ac all over 2a. Okay? So it has a catchy little tune to it. Yes, I understand you're in high school, so you don't want to admit that you ever listen to nursery rhymes. I get it. Wait till you have your own kids, and you're holding your own child, and you realize that nursery rhyme is the only thing that calms them down. You will become nursery rhyme fanatics. Huh? Sure they are. So, here's a little jingle when I was a kid. This was a McDonald's commercial. Ready? Big Mac fillet of fish, quarter pound of French fries, icy Coke, bake shake, sundaes, and apple pies.
Oh yeah.
Okay, that's something from when I was a kid. An advertising slogan for McDonald's. Was McDonald's really bright having that kind of slogan? This was 30 years ago, and I still remember the slogan. I understand. So, was McDonald's smart doing that? Oh my gosh, heck yeah! What other slogans do I know? That's pretty much it. Yeah, where's the beef? But it wasn't like, where's the beef was just that. But I mean, I remember that whole commercial. And they would sit there and they would flash Big Mac, filet of fish, quarter pounder, French fries.
icy Coke, milkshake, sundaes, and apple pies. And they would show pictures of it, and that's all the commercial was. And then it had McDonald's, the M logo at the end for McDonald's. It was like, dude, I'm going. So, jingles do work. Okay, so, is there another way to solve this problem? Yeah, you could look, you can say, oh, I do have a GCF, and that is 2x, and that leaves me x minus 4, and so I could set each of those equal to 0. So I get x is equal to 0, so I divide by 2, and I get x is equal to 4. Guess what? If I use the quadratic formula, what would the quadratic formula say the answers are? 6 and 12? I showed that it's 0 and 4 up here, so should the quadratic formula show me different? Quadratic formula would work on it if I got stuck. That's my go-to. Backside, I have 2x squared plus 18x equals negative 40. Does the quadratic formula work on this problem as it sits? Does the quadratic formula work on this problem as it sits?
Yeah, maybe. No.
Why? It's not equal to 0. Good, thank you. All right, so in order to make the quadratic formula work, it has to be equal to 0. So I am going to add 40 to both sides. Or I could have subtracted 2x, I could have subtracted 18x, and the answer is still the same. So sometimes you might get to this point going, oh my gosh, everything's divisible by 2. I have a GCF, sweet! And then you could say, oh my gosh, the two numbers that multiply together to give me 20 and also add to give me 9 are 4 and 5. Sweet! And so you could also realize, oh, this would factor to this, and that's awesome. And that means that I'm going to take each of these and set these each equal to 0. And I get the answers of negative 4 and negative 5. Guess what the quadratic formula would have given me for answers? Same thing. Do you think the quadratic formula matters if I had factored out a greatest common factor or not? No, quadratic formula doesn't care. Quadratic formula says, hey, my A value is 2, my B value is 18, my C value is 40. Guess what? Could I use the quadratic formula on this and get the same result? Yes. Okay, if I didn't factor out a GCF and I used the quadratic formula, it just means at the very end I would probably had to have divided by 2 to get to my answers. Okay? If I realized there was a GCF, then use the quadratic formula, guess what you don't have to do at the very end? Divide by the greatest common factor, which in this case was 2. Sometimes you might be given a problem that looks like this. 2x squared plus 3 equals negative 5x. Does the quadratic formula work on this?
No.
Not yet. What do I have to do first? Equals 0. So I can either move the 5x over by adding it to both sides, or I can move the 2x squared and then plus 3 over by subtracting 2x squared and minus 3. So I'm going to do just the single move. Oh, no. Stop. Eraser. On there, give me 2. 2 plus 3 equals 0. Okay, no greatest common factor. Maybe it would factor out. My dream number is 6. And the factors of that are 2 and 3. So it would factor out. Or my A value is 2, my B value is 5, and my C value is 3. Quadratic x equals negative b plus minus square root. B squared minus 4ac all over 2a. Reduce and take out of the radical. Yup.
Will it ever be like 2x squared plus 3 plus 5x, or will it always be?
Oh. So could it be like this? This is the exact same thing. This just isn't in standard form. So you need to change the order of it. So this is a positive 3, so it stays positive 3. This is a positive 5x, so that becomes positive 5x. And so
If it's out of order, change the order. And what you have to realize is your a value is always attached to the x squared term. Your b value is always attached to the x term, and your c value is your constant. So no matter what order, this is still my a value. This is still my b value, and this is still my c value. It's just in a different order.
It's not ordered. You have to like.
It's your choice. If you're able to not manipulate it, and you realize A, B, and C are out of order, and you put A, B, and C in the order in the problem, you nailed it. Okay? The problem becomes this, though, Mac. When someone says, oh, this is A, this is B, and this is C, no, the B value should have X attached to it. If it doesn't, it's wrong. Okay? So, there's all kinds of ways to do this. If I chose to factor this problem and solve, if that worked, your answer is the exact same as if you plugged into the quadratic formula. It works for you. I think you're okay with this. It's equal to 0. My a value is 1. My b value is -2. My c value is -5. X is equal to -b plus or minus square root b squared minus 4ac all over 2a. Okay, my a value is 1 or -2, excuse me. B squared is this 4ac all over 2a. -2, 2. -2 quantity squared, 4 plus 20 over 2. 2 plus or minus square root 24 over 2. Square root of 24 breaks down to 4 and 6. 4 and 6 breaks down to this. So my reduced version is this. Because I could reduce each of these. Question. Would this have factored out? Would our original problem factored out? No. Why not? Because we have a square root that wasn't a perfect square. We still have something under the radical. So you had no choice on this problem other than to use the quadratic formula, which is okay. Quadratic formula works on every quadratic problem. Okay? We're not putting an asterisk next to it saying quadratic formula works on all except for there are 2 squares. No, it works on all quadratics. Okay? Quadratic, you will always have an a value. Why will you always have an a value when using the quadratic formula? Which value is my a value? The squared. Squared says quadratic. If you don't have an a value and you just have a b and a c value, it's linear. Guess what doesn't work with linear? Quadratic. Why doesn't it work? Because my x equals -b plus or minus square root b squared minus 4ac all over 2a. If my a value is 0, that means you're dividing your whole problem by 0. And if 0 is under the rest of the problem, it makes it undefined. So linear does not solve by quadratic ever. It's undefined. Yeah.
Can you move it down?
Last thing. We good? Here we go. All right. 4x to the third minus 18x squared equals 10x. Okay? It's raised to the third power. This is a cubic situation. So let's move everything over to the correct side. So I have 4x to the third minus 18x squared minus 10x equals 0. Do I have a greatest common factor that's a number? 4 doesn't go into 18 evenly. 2 works,
2x.
and 2 and x work. Okay, I like it. So I have a greatest common factor of 2x. And that leaves me here. What does that make that? 2x squared. Awesome. What does it make this? -9x. Thank you for keeping the sign. And that makes this? -5. Okay, and the whole thing's equal to 0. So in this scenario, you have 2x and 0. So you have this, 2x equals 0, so x is equal to 0. Here's one of my solutions. How many more solutions are there? There's 2 more. I should have a total of 3 solutions. How do I know that? It's raised to the 3rd power. Okay? If you have a greatest common factor and x factors out, that means one of your x values is 0. It crosses the x-axis at 0, 0. Sweet. Okay? Can I factor this? I don't know. Maybe. What 2 numbers multiply together to give me negative 10, add together to give me negative 9? Negative 10 and positive 1. Oh, it would factor. If it doesn't factor, does the quadratic formula work on the quadratic? Okay, which way is the right way to do it? The way that makes most sense to you. The way that makes sense to you in order for you to establish a correct answer. What answer do you think students are going to leave out once they use the quadratic on this? What answer do you think will get forgotten about? What answer? I have one answer up there on the board right now. I have one answer up on the board right now. X equals 0. That's one answer. Why will people forget about that answer? Because that's up here, and now we're going to go, okay, my A value is 2, my B value is negative 9, my C value is negative 5, and I know that X is equal to negative B plus or minus square root B squared minus 4AC all over 2A. And I'll plug those values in because I'm proud. X equals negative 9 plus or minus 9 squared minus 4AC all over 2A. And you do all of this work to get X is equal to blah, 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 blah. Something like that. Over blah. And you're like, dude, here's my answer. And you forgot which answer. X equals 0. So be proud. Hey, you got an answer. Bring it up straight on down. X is equal to 0. And X is also equal to these 2 other terms. Did they all factor out appropriately? Did they come out to whole numbers? Did they come out with numbers that have a radical sign attached to it? Maybe, maybe, maybe. We good? All right. Let's review a smidge more. Guys and girls, I need you to see if you can break these down. All I want you to do is break these down. Break these down into smaller radicals. Find the perfect squares. If they don't break down, tell me they don't break down. Who saw this being this?
I got 4
And so square root of 16 is 4, so 4 root 3. Awesome. Some of you might have seen this as 4 times 12, which gives you 2 root 12, and then 2 root 12 will break down to 4 times 3, so square root 4, and that'll give you the same answer. So, if you don't break it down all the way. Some of you might see this root 48, you break 48 down, and you're like 2 and 24, and that's 2, and so that's prime, and then 2 and 12, and then that breaks down to 2 and 6, and then 6 breaks down to 2 and 3, so you know that 2, 2, 2, 2, 3, so 2 times 2, 4, square root of 4, 2, next 2 times 2 is 4, or square root of 4, which is 2, 2 times 2 is 4, okay? Root 24 breaks down to 4 times 6, which is 2 square root 6. That's done. 18 breaks down to 9 and 2, which is 3 root 2. That's all done. And root 23, the answer is just root 23. Why is that? Yeah, it's not a perfect square. I take it back. 1 times 23. But yeah, we're not really worried about that. We're worried about 4s and 9s and things like that. What about, let's see, what happens? I will give you a clue. This is number 6 from your homework. How do I do it? Yeah, bring that 36x over. It's equal to 0. Can I use the quadratic formula on this?
Yeah.
What do you think? Preston, what do you think? Thank you much. Thank you much. Thank you much. Can I use the quadratic formula? There is an x squared value. That's awesome. What else is there? Huh?
It's cubic.
Cubic. Quadratic works with x squared. Cubic doesn't. So then we have to say, okay, we can either say, okay, I'm stuck, I give up, I want to draw a palm tree on a beach with a beach ball. Sweet, a bird flying with the sun. Or you can say, oh, I have a GCF of x, and that leaves me this. Yay? Which gives me, this is my first solution. And I'm going to draw myself an arrow all the way down because that's going to be, because if not, I'll forget. And then I can say, oh, you know what? My A value is 1, my B value is -5, my C value is -36. And I know that x is equal to -b. Shoot. Plus or minus, I didn't want the -b there. I wanted to put the values in -b, -5, plus or minus square root. B squared minus 4, C. Solve this. So you get 5 plus or minus 25 plus 144 over 2. I got lucky. I did it quick. This is 5 plus or minus the square root of 169 over 2. So 169 perfect square. Yes. Good. So I get 5 plus or minus 13 over 2. 5 plus 13 is 18 over 2. 18 over 2 is 9. 5 minus 13 is -8 over 2, which is equal to -4. Here's my 2 answers. Yay, I'm done. Oh, yeah, x equals 0 as well. Okay, guys and girls, your assignment for next time is worksheet 6A, which is page 105 and 106. Okay? It should be good to go with. What I'll do is I will work all of these out and I will post them. Let's see, where can I post them? I post them on Schoology as a PDF that you will be able to see later tonight, but you do have a quiz tomorrow. Got it?
Like an online quiz or?
No, it's pencil paper.